Can you see my slide? All right, thank you. All right, so this is phosphorus removal during water and wastewater treatment. The methods that I'm going to explain to you today is known as chemical precipitation methods. Yeah? There are many methods that can be used. Later, we are going to discuss. In the following lecture, we are going to discuss and to explore about biological technology. There are few joint removal technology, including anoxic, oxic treatment that can be used to remove the phosphorus. But today we are going to explore a simple version, yeah, for phosphorus removal, which is chemical precipitation methods. Yeah. For your information, yeah, adding of the chemical into wastewater to remove certain substance is a common method. Yeah? For example, just now I mentioned to you, we add calcium to reduce the effect of sodium. So this is known as antagonistic effect. Yeah? The role of one ion, the role of one substance to reduce the toxicity of other substance. Yeah? So chemical precipitation of phosphorus is frequently utilized method. Yeah? Either as a primary removal process or as is combined with the biological removal process. Yeah? Okay. Why phosphorus? Okay, so in this course we shall explore on phosphorus and nitrogen. Yeah, the major reason is phosphorus are the limiting parameters that will determine whether eutrophication will occur or not. Yeah, I repeat. Yeah, why phosphorus? Because phosphorus is the limiting parameters that will determine whether the eutrophication will occur or not. We all know, yeah, eutrophication is a state, is a situation when we have algal bloom. Yeah, especially in open water bodies. Yeah, not only in open water bodies, it can also happen in water tank. Yeah, so eutrophication. So this is the scenario, yeah, that we have to pay more attention because what does it mean by limiting factor? Limiting factor means to say that phosphorus concentration of phosphorus will determine whether eutrophication will occur or not. That's what I mean by limiting factor. Uh, Meaning to say that at the right ratio of phosphorus and nitrogen, yeah, then only eutrophication will occur. Yeah, we cannot say that we have phosphorus, we have nitrogen, so that eutrophication will occur. Not necessarily that. It will only occur at the correct ratio of phosphorus to nitrogen. Okay. For this reason, chemical addition is frequently the phosphorus removal method of choice, yeah, for small and medium size of plant. Yeah, so they are also known as enhanced biological phosphorus removal. Yeah. Okay, there are three groups. Yeah, so let's explore. What does it mean? What can we tell more about phosphorus in water and wastewater? They can be classified into three. The first one is polyphosphate. The second one is orthophosphate, and the third one is organic phosphate. Yeah, the first and second one can be removed through biological treatment or chemical wastewater treatment, but the third one, yeah, organic phosphate, it will remain forever, yeah, in treated water or treated wastewater. Yeah, therefore, there are one concept to be used for phosphorus removal. Yeah, so that's why I mentioned just now. This is known as antagonistic effect. Yeah, the role of one ion, the role of one substance to reduce the toxicity of other substance. Yeah, for example, addition of potassium into water with high concentration of sodium can reduce the inhibition effect during biological treatment. Yeah, addition of potassium, addition of calcium, and this can reduce the effect of sodium. Yeah, in this topic, we shall see how aluminium and ferric chloride, yeah, ferric chloride is iron. Yeah, so give me 1 minute. Yeah. Okay. Ferric chloride ni iron lah that can be used to remove the phosphorus or to reduce the effect of phosphorus in water bodies or wastewater bodies. Okay, so this are short story about phosphorus. So now the calculation part, determination of dose. Now we need to know, we need to calculate how much the aluminium is required based on the phosphorus level. For example, this one. In this topic, we shall see how aluminium and ferric chloride. So I have two examples today. First, the calculation on how to calculate aluminium, how much aluminium is required based on the phosphorus concentration or phosphorus available in water or wastewater. Second is on ferric chloride, because these two substances can be used for phosphorus removal. Okay, so the first equation, equation 8.3, y is equal to a over 1 plus be minus cxe. Okay, this equation, what is y? Y is moles aluminium required per mole soluble phosphate removed. So in this case, we use aluminium to remove the phosphorus. Okay, why phosphate? Okay, most of the time, when we measure the concentration of phosphorus in lab, it shall not be measured as phosphorus. Normally it will be measured as phosphate. Why? Because phosphate is the ion that exists in phosphorus. So phosphorus will be measured as phosphate. So in my slide, whenever you see phosphate, we are actually referring to phosphorus. Okay, A is equal to 0.8. These are the factor. Normally in the question, you will be provided with this value. B is equal to minus 0.95. How do they develop this equation and they got this constant? So normally the equation and these are not, being developed from Monod equation, and they develop this constant based on the previous study. They have monitored the trend so that they can get this constant. Okay, C is equal to 1.9, Xe is equal to soluble phosphorus concentration at the chemical application point. Okay, as equation 8.3 was derived as a best fit formula for empirical data, it is valid only for a limited range of residual phosphorus, approximately about 0.9 to 0.1 to 0.8. For residual phosphorus concentration above 0.8 milligram per liter, the value of Y should be assumed to be 1, no excess over the stoichiometric amount indicated. Okay, so this equation and the constant that provided to us in this example, the limitation is they have come up with a constant up to 0.99, up to the Y value of 0.99. If exceed that level, then it's assumed to be 1. Okay, example 1. Alum addition for phosphorus removal, design consideration. Sorry, the limiting is 0.8. So more than 0.8, the value of Y should be taken as 1. So this indicates that when the experiment was conducted, the tested value only up to 0.8. Exceeding 0.8, Y is always equal to 1. Okay, example 1. So influent plant flow rate, yes, you are given for as usual. When we calculate for the water treatment or wastewater treatment, we need to know the flow rate. So in this case, influent plant flow rate is 37,850 meter cube per day. Residual, the residual in the influent soluble phosphorus concentration at the point of chemical application. This sentence, the second point, is about the it tells us about the existing phosphorus. Existing phosphorus in water bodies is equal to 3 milligram per liter. Yeah, a residual effluent soluble concentration of phosphorus is 0.4 is required. 0.4 is the limit set by the city council, set by the authorities. Yeah, I repeat. Yeah, 37,000 is the flow rate. Okay, is the incoming flow for that particular plant. Point number two, 3 milligram per liter is the existing phosphorus concentration in that water or wastewater bodies. Yeah. Point number three is the target or, or the limit set by the authorities. Yeah, the target to achieve, yeah, the target of the phosphorus concentration. Yeah. Okay, so knowing the target, yeah, we need to know the target. This is an important information because we can set what is supposed to be the aluminium required so that we can remove the phosphorus to achieve the target phosphorus level, yeah, in the effluent, which is in this case equal to 0.4. Yeah. Okay, the amount of soluble phosphorus to be removed in kilogram per day as follows. First, we have to calculate the amount of phosphorus to be removed per day. P is equal to 3 minus 0.4 milligram per liter. Yeah, 3 is given minus 0.4. 3 in existing system minus 0.4 is the allowable limit. Yeah, so times the flow rate. This is for to convert the unit conversion. So solving this equation, you will get the amount of soluble phosphorus to be removed is equal to 98.4 kg per day. Okay, this is equivalent to 99.4 kg per day over 31 kg per kg mole of phosphorus. Okay, 31 kg per kg mole. What is this value? Phosphorus, the standard value to be used for phosphorus when you refer to a periodic table is 31. Okay, let me check for you. Periodic table. This one. Okay. Yeah, the atomic mass. Yeah, can see. Yeah, this is a phosphorus. Yeah. So whenever for this reason, to solve this kind of example, we are always to use the value of 31. You can use 30.97. Yeah, because this is the standard value. Yeah, 30.97 the atomic mass, yeah, for phosphorus. Okay, then you divide with the atomic mass, then you will get in kg mole. Yeah? So this is equivalent to 3.17 kg mole. Okay, up to this point, do you have any question? No
No,
question.
that's
Yeah?
it.
Okay, thank you. Alright, next, the amount of aluminum ions required in calculated, from equation 8.3 as follows. So now this is the time for us to use the equation, that we have seen before, which is this one. Okay, y is equal to a over 1 plus be minus to the power of minus cxe. So in this case, a is equal to 0.8 is given. Okay, 1 plus b is equal to minus 0.95 and c is equal to I remember the equation. C is equal to minus 1.9. What is the value? Sorry, let me check because I can't remember. Okay. So in this case, yeah, we have y, a is equal to 0.8, yeah. So b is equal to minus 0.95, yeah, because a plus b. Okay, the equation is 1 plus b. So 1 plus b, since the value of b is equal to minus 0.95, so 1 minus 0.95 exponential, yeah, exponential, this one is exponential. 1.9, 1.9 is the value of c times 0.4, yeah, times 0.4 is the value of xe. Okay, the value of xe is also given lah, the value of xe is the soluble phosphorus at the chemical application point. So in our case, is the limit, yeah, the limit, the set limit target, the target set limit by the authorities, yeah. Okay, then consequently then you solve for the equation, you get 1.44 kg mole, yeah. So you want to try, yeah, whether you can get 1.44 or not. Yeah, this one, y is equal to 0.8 over 1 minus, right? You can try, yeah, so that you know that you should be able to get 1.44. You can try now, 1 minute. Okay, did you manage to get 1.44?
Yes.
Okay, great. Okay, thank you. Consequently, the amount of aluminum ions required per day, now the one that you have calculated before is the aluminum ion in the forms of mole. It doesn't help us much, yeah, because we are not interested in the form of moles, and we would like to know in the form of kg per day. That will tell us a lot, yeah. So for this reason, you need to further doing the calculation, yeah. So 3.17 kg mole of phosphorus, yeah, 3.17 from previous, yeah, previous calculation, times 1.44 moles, then you will get 4.57 kg mole of aluminium, yeah. So as the molecular weight for the aluminum ions is 27, yeah, the molecular weight just now 31, okay, here, okay, 31 here is the atomic mass. Okay, and now we are talking about the aluminum, the molecular weight. The molecular weight is 27, also a standard value. This is also a standard value, 27. Yeah. So this is converted to mass of aluminum ions per day as follow. So 4.57 times 27, so you will get 123 kg of aluminum ion per day. Okay, given dry alum basis, alum is aluminium equal to 9.1, alum solution contain about 0.059 kg per liter aluminum ion. So 1 to 3, this is given, yeah, the dry alum basis about 9.1. So 1 to 3 aluminium per zero, divided by 0.091 from here, from this percentage. So you will get the total volume, total weight of the alum that have to be added, aluminium, which has to be added is 1356 kg of alum. Yeah. So the amount of liquid alum required, because sometimes in certain, because the one that we have in our lab is in the form of powder alum, so uh, in the form of powder, so we can measure as kg. Yeah, however, in water treatment plant, normally it will be added as in the form of solution. So for this reason, we need to calculate, based on the how much that required in form of volume. Yeah. So in this case, 1 to 3 kg aluminium divided by 0.0959 kg per liter. This one is also given the information. So that in short, about 2092 liters of aluminium is required. Okay, You can spend 2 minutes to check this calculation. Oh, come back. Okay. Do you have any question? No question, eh? Any question from the floor? Dry alum basis, you need this information if you are going to use to calculate the alum when it exists in the form of powder. Yeah, but normally in wastewater treatment plant, in case that they use alum, so they are being added. The alum are being added in the form of solution. Yeah, that's why we need to calculate in terms of liters. Yeah, for that reason, you need to know what is the alum solution content in every kg per liter of aluminium ion. Okay. All right. If there is no further question, then this is going to be your assignment. Okay, your assignment number 2 is divided into 2. Yeah, because this is too short. This calculation is too short and too easy. Yeah, this is exactly this example, but I changed to ferric chloride. Okay, so you need to conduct the calculation based on the ferric chloride. Bear in mind, yeah, that you need to, now you are given the molecular weight already. I shouldn't have provided this value, 56. You should be able to find from the periodic table. Yeah. So the molecular weight now is 56. It's no longer 31. Why? Because now we are using ferric chloride, yeah, to remove as the agent for the removal of phosphorus. You are also being given the new value for the constant, and you are given you have to calculate both the volume as well as the weight of the ferric chloride required, um, if we are to remove the phosphorus at a certain level. Okay, so in this case, the existing phosphorus, the concentration of phosphorus in water bodies is 3, and the target concentration, the allowable limit is 1 milligram per liter. Okay, this is the part 1 of your assignment number 2, which is to be submitted individually in week 7. Yeah, after Raya lah, after the Eid, after the semester break, which is to submit in week 7 before your test. Okay. Interestingly, surprisingly, time running very fast, and we have to discuss about the test. The test is going to be conducted in week 7 during lecture. Okay, in week 7 during lecture. So it will cover from lecture 1 until lecture 6. Yeah? So lecture 1 until lecture 6. Basically, the one that we explore today is lecture 4. So I will continue with lecture 5, yeah, so that we don't have to conduct any replacement, since next week there will be no lecture, because next week on Tuesday is a public holiday. Yeah. Alright, so that's why I provided you with the assignment. This is individual assignment. Yeah, individual assignment. And another one assignment is this one. This is a breakout session. You have to divide, you are going to divide into four groups, group assignment, and you have to discuss about water reclamation technology. This is more or less, if you still remember our breakout session before, but more details lah, because you are given about 3 to 4 weeks to complete the assignment. Recommend the most suitable technology to be used and discuss the potential of membrane types as the post treatment. Number two is about absorption technology. Number three is about moving bed bioreactor. Number four is about anaerobic system. Okay, I'm not in the position to decide who will be in which group. Yeah, I think maybe Tinesh can help me to arrange for this. In my opinion, you are free to decide which one is your group members. Yeah, but bear in mind that we please do not leave our friend Tobin. Yeah, because we have one mobility student here, and I think we have Chi Win. Yeah, she is from the United States. She is currently in the United States. Yeah, so she has to be included in one of the group too. Yeah, maybe Jessica can help me. Jessica or Song can help me to reach our friend in the United States, yeah, so that please include her in this assignment. So 50% of the marks for assignment number two, because we have 3 marks, 3 or 4 marks for assignment number two. So 50% from the individual assignment and another 50% from the group assignment. So the group assignment, again, you don't have to submit in the form of report because this is only the assignment. Yeah, I prefer to be as simple as you can. So again, you are going to submit in the form of slide. Yeah, so not more than 2 slides. Yeah, not more than 2 slides. Yeah, so submit in the form of slide presentation to the maximum. The recommended numbers of slide is 2. Yes, please do not less than 2 and please do not exceed 2. Okay, all right. Submit in week 7, after the semester break. Uh, okay. Before we continue, do you have any question regarding on assignment number 2? No question.
No, okay.
Okay. Okay. Impact of chemical addition on plant operation. Okay. Knowing the capability of the chemicals for the removal of certain substance, yeah, they are very good. Yeah, we can get a higher removal efficiency when we apply the chemical techniques. Yeah, when we add some chemical, certain chemical to reduce the effect of certain chemical. For example, in this case of phosphorus, they can be effectively removed. Nevertheless, yeah, there are disadvantages. Yeah? The disadvantages is the sludge generation. Yeah, you add the ferric chloride or the aluminum into the wastewater or water, that it will combine with the sludge. Yeah? So one of your friends is now presented in her assignment. So this addition of chemical for precipitation of phosphorus will generate additional or inert chemical sludge at the point of addition. Yeah, so that will first, it will increase the volume of the sludge because addition of these chemicals exist in the form of physical, in the form of suspended solid. Yeah. Second, it will cause problem to the in terms of sludge management. You know why? Because addition of the chemicals into the during wastewater treatment will make the sludge being classified as the hazardous waste. Okay, you know, sludge from our water and wastewater treatment, they are to be treated in a special wastewater in a special landfill because they are considered as hazardous waste. Yeah, why hazardous waste? Yeah, they are just treating water. Yeah, water from the river, water from the ponds, water from the lakes. just treating domestic wastewater, not even industrial wastewater. So why the sludge generated from this domestic water and wastewater treatment are considered as classified as hazardous waste? Because due to the addition of chemicals, yeah, including aluminium, PAC, ferric chloride. Yeah, so uh, at this moment, these are the most common technology lah, that being used for the treatment, even though they are facing uh, challenge, in terms of management of the sludge. Okay. Next, effect on sludge settling. So in addition to increasing waste solid generation or dryness basis, addition of chemicals such as alum and ferric will impact sludge settling and dewatering properties. So having this chemical will also cause will reduce the capacity of the sludge to settle to the bottom part, yeah, and also will affect the dewatering process during sludge treatment. Yeah, dewatering process is the process to remove water or moisture content during a sludge treatment. So having this chemical, yeah, it will delay a little bit lah. Yeah, it will cause, it will disrupt, it will interfere the process. Yeah, interfere the process of dewatering as well as the process of sludge settling in primary tank as well as secondary tank. Yeah, right. Okay. So next, okay, lecture 5. Yeah. Okay, lecture 5 is on wastewater treatment. Okay, wastewater treatment. So this is to recap the one that we have studied before during in your year 3. So the first one is screening, communities, grit removal, oil and grease trap, pre-aeration. They are considered as prelim treatment. Next is the primary treatment. Now we are in the stage of secondary treatment. Yeah, secondary treatment of biological and physical process. Next, we are going to explore on the tertiary treatment. Okay, so what happened during biological treatment? Yeah, we know that there are two types of biological treatment. The first one is known as aerobic process. Yeah, aerobic process is the most common technology, that they apply. Because this is a simple technology, even though it's require high energy usage, high energy consumption, because we need to use a blower to pump in the oxygen into the wastewater or water tank. However, the aerobic process are more familiar. Yeah. So what is aerobic process? Aerobic process is the process of organic matter. Organic matter here means to say that the wastewater plus the oxygen. In this condition, in aerobic condition, oxygen are being utilized by microorganism to break down the waste. Yeah, which it will produce carbon dioxide, water, as well as the new cell. Yeah. On the other hand, we have another methods, another system, another process, also a biological process, which is known as anaerobic process. Okay, anaerobic process is the process Okay, anaerobic process is the process where microbes still utilize the microbes, but in a condition where no oxygen at all, without oxygen. So in this case, in these circumstances, and oxygen is considered as a potent inhibitors. If oxygen can enter the system, it will kill the anaerobic microorganism. Okay, so in this process, it will produce methane, carbon, most of them 60% of the product are methane, carbon dioxide, some ammonia, hydrogen sulfide, as well as the nucleus. Okay, so the major difference are the oxygen. Aerobic process is where oxygen is available and microbes utilize them. Yeah, microbes need to utilize the oxygen in order to break down the waste. Yeah, and while in anaerobic process, there is no oxygen available. So microbes, the anaerobic microbes and aerobic microbes, there are different types of microorganisms. Anaerobic microorganisms, they do not require any oxygen. In fact, if you expose to oxygen, um, it considered as a toxic environment to them. Okay, they will not perform in the condition where oxygen is available because they don't use oxygen to biodegrade the waste. Okay, so why we must use biological treatment? Yeah, because it's effective for removal of organics, stabilization of biodegradable material. Removal can be used for removal of heavy metal, less effective. Yeah, that's why I said just now in one of our friends' presentations, she presented on rubber wastewater treatment. Yeah, so I believe that that's why they use electrochemical treatment, yeah, to remove the heavy metal, the inorganic material, yeah, in rubber wastewater. Next, removal of color, also less effective. Okay, because those microorganisms, they only prefer to eat, to biodegrade or to oxidize the organic substance. Yeah, organic substance ni macam apa? It's like food processing wastewater, yeah, domestic wastewater, livestock wastewater, yeah, livestock wastewater. What else? Um, Industrial wastewater, not exactly, because some of the industrial wastewater are not really organic lah, unless you are talking about food and beverage industry. Yes, it's contain high sugar. If you are talking about molasses wastewater, yes, it's contain high sugar. Okay, so if you are to remove the inorganic material, that will be another chapter. Yeah, another chapter after week 7. We will see the technology available for the removal of inorganic materials. Okay, so let's see the biochemical oxidation and the kinetics. Okay, quantity of oxygen demand. Yeah, why they use oxygen? Yeah, oxygen demand is used to determine the quantity of oxygen that will be required. Yeah, so normally we will measure the oxygen available because the oxygen can tell us the load of the pollutant. How? Yeah, how? Because microbes will utilize the oxygen to biodegrade the waste. That's why we need to know what is the oxygen available or oxygen which has been used, so that it will be uh, it can tell us about the load of the pollutant. So knowing this, we can determine the correct size of the waste treatment facilities, as well as we can measure the efficiencies of the treatment process. Okay. So the existence and absence of the microbial population may affect the biodegradation of the organic matter. Yeah, because most biological treatment have a primary purpose of removing the organic matter, because these are the spirit, of employing the biological treatment. Uh, I have experience using biological methods to treat textile wastewater. No, microbes won't eat those kinds. Yeah, you put in, into the system blue wastewater, it will come out as blue wastewater. It will come out, the effluent will come out as a blue wastewater, exactly the same. Because microbes, they won't eat those inorganic materials. Yeah, so for that reason, I think that was in 2019. So we decided to combine with the adsorption technologies. Yeah, so first we conduct the anaerobic process as a biological treatment. Then the effluent come out from the anaerobic system and it was further treated with the physical chemical process, which is adsorption technology. Adsorption technology is good Yeah, because they don't involve any microorganism, any living organism. It's a process where pollutants stick on the surface of the media so that it can further remove the colors, yeah, especially the colors. Okay. So there are two types, yeah, of the aerobic wastewater treatment. These are the groups. Yeah, the first one is known as suspended growth process. The second one is known as attached growth or biofilm process. Yeah. So the first one, stabilization pond or oxidation pond, erected lagoon, activated sludge process, and sequencing a batch reactor. These are the suspended growth process. In other words, suspended growth process are the process where involve a tank or a lagoon without any media, without any support carrier. Okay, without any support carrier. So while the attached growth process, they are very easily to differentiate, yeah, because suspended growth process, you employ only the tank, only a pond, yeah, without any support carrier. If you use any support carrier, so that is already considered as attached growth or biofilm. So, for example, rotating biological contactors, yeah, trickling filters, biological aerated filters, and moving bed bioreactor. Yeah. So in suspended growth system, the cytoflocs retain the microorganism, yeah, meaning they can be recycled for further treatment. Yeah, for example, in activated sludge process, we use to recycle the sludge. Yeah. So by contrast, in attached growth system, we use a media, we use a medium to retain to this allow the microbes to grow. So in this case, we use a medium, we use a support carrier to allow the microbes to grow. Yeah. Okay. Right. So maybe we can watch one video, yeah, on the slash process. Yeah.
Secondary treatment. Secondary treatment is the heart of the wastewater treatment process. Whereas the previous steps of treatment consisted in removing the suspended solids by settlement, this step of treatment consists in removing the major part of dissolved pollution, mainly BOD5 and ammonia. During the aeration phase, specific bacteria eat the dissolved organic matter and transform it into suspended solids. Other specific bacteria oxidize the ammonia into nitrates, then nitrates. During the non-aeration phase, called also anoxic phase, other type of bacteria convert the nitrates into nitrogen gas, which is released into the atmosphere. To ensure a good balance between the bacteria settled in the clarifiers are continuously returned at the inlet of the tank. They are called return-activated sludge. The upstream part of the activated sludge tank is covered so that odorous air is trapped and extracted towards odor treatment units.
Okay, so these are basically the summary, yeah, of the video. Yeah. So activated sludge system. First, we have wastewater and the screening and the communities. Communities, the function of the communities is to cut off, yeah, the debris into small particles. Therefore, it will allow the removal of some of the fine particles in the grid chamber. So the grid comprised of sand, gravel, yeah, so they are to be removed in grid chamber. Following grid process, it will be primary settling. Yeah, primary settling. there will be a large amount of sludge to be settled in this tank. So after primary settling, there will be aeration process. This is the important process because this is the process where we supply the oxygen. Okay, so the sludge, some of the sludge will be returned as activated sludge. So it will come back into the aeration process. Why do we need to promote the return activated sludge? Because it can we are having the recycling process. Yeah, we can have more microorganism. Okay, so we can, so that it can further improve the removal rate. Yeah, okay, it can further improve the pollutant removal. Then there will be a waste activated sludge. Some of the sludge will be returned as return activated sludge, and the rest will be going to for the sludge treatment as waste activated sludge. Okay, so these are the closed loops. Yeah, how does it look in a secondary tank, or known as settling tank and aeration tank? Okay, some of the sludge will return as activated sludge, where it will promote more microorganism to be developed. Okay, so there are two terms that you have to be familiar with. The first one is mixed liquor. Mixed liquor means is raw sewage or biological mess. Yeah, what is mixed liquor suspended solid? Mixed liquor suspended solid is suspended solid, yeah, concentration in wastewater to be treated. Yeah. Mixed liquid suspended solid normally comprise of organic and inorganic solid. Yeah. Mixed liquid volatile suspended solid, they are 100% organic. Yeah. So MLVSS will tell us the concentration of microorganism. Yeah. So let's say when you take a sample of a sludge, to know the basically the percentage of microorganism, you can check the volatile suspended solid concentration. Yeah, you can check the percentage of volatile suspended solid. Yeah, um, um, you can check the percentage of volatile suspended solid. Yeah, for example, when you take a sample of sludge, yeah, you measure the percentage of volatile suspended solid is only 7%. So that's indicate only 7. Let's say you take a sample of 1 kg of sludge, then you measure only 7% of volatile suspended solid. So that indicates only 7% in 1 kg comprise of microorganism. Yeah, comprise of microorganism. So you need to know the difference between these two. First, suspended solid, only the suspended solid, which is known as mixed liquid suspended solid, which can exist in the forms of organic and inorganic. While if we are talking about mixed liquid volatile suspended solid, is contain all organic, which is the microorganism. Okay, so this against the aeration tank, the influent, and the return activated sludge. Yeah? So normally the mixed liquid suspended solid, the concentration is around 2000 milligram per liter. Yeah, but after few recycling of the return activated sludge, the mixed liquid suspended solid can increase up to 5000 milligram per liter. Yeah. Okay, these are the activated sludge system with the fine bubbles, yeah, and these are the process design. Okay, so biomass yield. Later we have an example of the calculation. Yeah, so biomass yield in milligram of VSS per milligram of BOD5. Yeah, so in a conventional process, normally this value, the Y value is between 0.5 to 0.67. Yeah, so the volumetric loading is around 0.3 to 0.6. What is volumetric loading? Ability of bacteria to consume the waste. Yeah. Next, MLSS, mixed liquid suspended solid, normally around 1,500 to 3,000 in a conventional process. The HRT is about 8 to 16 days. Yeah, 8 to 16 hours. Yeah. 8 to 16 days is too long. 8 to 16 hours. So we allows the bacteria to get in contact, with the food. So what is hydraulic retention time? Hydraulic retention time, we need to say that how long that we leave the wastewater inside the tank without any activities. So this is the period where we allow the waste to get intact with the microorganism. So that is hydraulic retention time. So recirculation ratio is about 0.25 to 0.5. Because why do we need to recirculate? That's why we have written activated sludge just now, because we would like to maintain the biomass in the aeration, because the more the recirculation, the more will be the microorganism. Yeah. Okay. Primary effluent, so our plant influent is mixed with the return activated sludge to form the mixed liquor. The mixed liquor is aerated, for a specified length of time. During aeration, the activated sludge organism use available organic matter as a source of food. Okay, let's watch another video. I hope this one is on the focusing on the return activated sludge.
Feel like you're doing the work of 4 people? With Monday.com Work OS, you can put all your repetitive work
Okay, this is very interesting, food to mass ratio, because if you have less food but you do have lots of microorganisms, also is not good. Yeah, they will be hungry. Yeah, not enough food, but too much food also not good. You know why? Because it can kill the microorganism. Yeah, when they eat a lot, they will die. Yeah. Okay. Okay, so the suspended solid, which is produced. Okay.
どうしたそんな浮かない顔をして誰の声なの
Okay, the suspended solid, which is produced by the process, and the additional organism become part of the activated sludge. So microbes will utilize the waste. They will eat the waste. They will oxidize the waste. So it will produce the inert material. So the inert material combined with the suspended solid, so that is actually the activated sludge. And the activated sludge is comprised of the sludge, is comprised of the organic, which is the waste, as well as the inert material, which is product from the biodegradation process. So the solid are then separated from the wastewater in the settling tank and returned to the effluent of the aeration tank as return activated sludge. Actually, I'm looking for another video which is uh, better as compared to this one. Um, Okay, so periodically the excess of solid and organism are removed from the system as waste activated sludge. Definitely, they will not be recycling everything for the entire life. They will some of the sludge will be removed as the waste activated sludge. Yes, only some will be written as activated sludge as return activated sludge RAS. So in this course, we are going in the example for this subtopic, we are going to calculate how much will be the RAS, how much will be the WAS, the waste activated sludge. Why we need to remove? Failure to remove waste solid will result in poor performance and loss of solid out of the system of a settling tank. We have to remove some of the solid because too much of solid can cause the competition in terms of the competition amongst the microorganism to get the food. For this reason, uh, it will cause the situation which is known as hollow granule. Hollow granule meaning to say that they are, you can see the flocks of the suspended solid, but inside nothing. That's why it's called hollow granule. So hollow granule is a bad indicator. Is an indicator for a poor performance of the activated sludge. Okay, for any biological treatment. So which indicates there are competition, there are competition between amongst the microbes, with the foods available. Not only that, the situation of hollow granule can also cause due to the effect of too much heavy metals concentration in wastewater, too much concentration of salt content. Salt content can also cause the situation of hollow granules. Well, you can see the particles, but it's actually nothing inside. Okay, so it's only air. So this is the circumstances that we would like to avoid. These are the parameters that can influence the performance, including temperature, loading, the aeration time, the amount of oxygen available. So the process control calculation, in order to check whether the sludge is okay or not, the sludge is in a good condition or not, we have to calculate. There are two examples. We need to know what will be the sludge settled volume. These are the equation. Settled sludge volume ml times 1000 ml of liter divided by sample volume. We have one example here. Okay, a 2000 ml sample of activated sludge is allowed to settle for 30 minutes. So SSB are the indicators. Are one of the indicators that being used to check whether the system is okay or not, is fine or not. So at the end of the setting time, the sludge volume is 1100 ml. At the beginning is 2000. So what is the 30-minute settle sludge volume? So after 30 minutes is actually 1100 times 1000. What is from the equation divided by the original volume of the sample. So SSB is equal to 550 ml per liter. Okay, you need to know this because you will need to check for you need to the SSV at 30 minutes are to be included in your equation when you need to calculate for sludge volume index. Okay, so sludge volume index is a quality indicator. It reflects the settling quality of the sludge. Yeah, so as the SVI increase, the sludge settle slower. Okay, what we want, the purpose of having the addition of the alum, the purpose of having coagulation process and chemical addition is for pollutant removal, and we want the sludge, the flocks to settle as quick as they can to the bottom part of the tank, yeah, so that we can reduce the overall operational cost. Yeah, so if you got the sludge volume higher, this indicates the sludge itself will be settled slower, does not compact well, and is likely to result in more effluent suspended solid. This an indicator to say that to tell us that in your effluent you will be collecting more suspended solid. Okay, so let's see example 2. The sample used in the previous example. Okay, now in the previous example we have calculated SSB 30 kan at 30 minutes. So in this case has an MLSS concentration of 2800 milligram per liter. So calculate the slash volume index and you substitute the SSB uh, from the previous example, example 1 times 1000. This is the conversion, divided by the MLSS. You will get 1196. Okay, what is the limit? The limit is 300, SPI. If the SPI is 300, that indicates that uh, these are going to happen. Yeah, the sludge will settle slower, it will not be, does not compact well, and there will be more suspended solid in your treated wastewater. Okay. Hmm, actually, I think we missed one video. Though. Hmm, ready. Where's the video? This is already. This also, I believe, already watched. Hmm. Yeah, I'm looking for a video that on the written video sludge. Okay, maybe this one. Oh, not this one. This one. Not this one. Actually, I couldn't find the video. We do actually have one video last time that can tell us how does it, what the real photo in wastewater treatment plant, where we can see the point, the entering point of the wastewater. For example, this one. Uh, okay. Is the whole photo just okay? The entering point, yeah, from the primary settling to the aeration tank, yeah, from aeration tank to the secondary tank. At the same time, there will be sludge who are written as the return activated sludge. Yeah, RAS. Yes, here is going to be RAS. Yeah, yeah, this point is RAS, while this one is known as WAS. Yeah, what is WAS? WAS means the waste, yeah, waste activated sludge. Yeah, waste. Okay, while this one is written, yeah, written, which is the sludge return to the aeration tank. Yeah, it will meet again with the fresh influent from the primary tank and goes into the aeration tank. So why do we need to employ these methods? Because it can increase, yeah, the amount of the microorganism. It will increase the population of microorganism because we allow more time, more cycle for the microbes to get intact with the new and fresh effluent. Fresh effluent where? From the primary settling tank. Okay, so I think that's all for today. Is there any question? Any question? Any question regarding on the assignment?
No, doctor.
Okay. So regarding on because there are four topics, so there will be four groups. Officially we do have 23, but unofficially we do have 24. Yeah, because one of our friend currently in the United States, so that 6 person per group. Yeah, 6 person per group. You are free to decide. Uh, and these are going to be submitted after the semester break. This and group work, and don't forget we do have one more assignment, which is on the phosphorus removal using the ferric chloride. Okay, so I think that's all for today. Thank you everyone for your kind attention, for your kind patience. Yeah, and please accept my apology for the interruption. So I'll see you in 2 weeks time. I will upload by tomorrow the assignment, both for individual and the group assignment. So please take your time to complete the assignment. You better complete it now before the semester break, because our test will be in week 7 during lecture time, during lecture hours, which is on okay, Raya, which is about 4 weeks from now lah. This is week Saturday. Yes, it's about 4 weeks from now. It will be on the 10th of May. There will be your first test in week 7. Okay, chapter cover chapter 1 from week 1 until week 6 lecture. Okay, all right. With that, I thank you everyone. Have a pleasant afternoon. Bye.
Thank you, doctor.
Thank you, doctor. Thank you,
Bye. Thank
doctor.
you.
Selamat berbuka, doktor.
Yes, selamat buka. Don't forget to fill
Thank
up
you, doctor.
the attendance.